This blue comfortable than white?
Yes, sir.
Okay, fine, yeah. Okay, now we'll start with the expansion of solids. It's a very, you check the advanced paper, we do have questions on this, and that too what happened is asking something very small idea based. So what you can call a mixed concept. The numericals are more asked on the mixed concept. That one. Somebody still not yet muted. Okay, why do the solids will expand? And before that, let me introduce with the small, the basic definitions. So first, as we know, heat. What is the heat? That one. It's a form of energy. That one. It's a form of energy, and the heat will flow from higher temperature to, it's a form of energy. This is the one first thing, and it flows from higher temperature to lower temperature. This energy, how it will be? It will be like electromagnetic radiation. So how do it will be? There are three processes are there: conduction, convection, radiation. In conduction, it will be due to atoms and electrons. And that later part we'll discuss. So it's a form of energy only, that one. What is the unit for energy? Either you can go for calorie or joule. So heat energy, rather than calling heat energy, call heat. Heat itself is called as, taken as to be energy, that one. So don't say heat energy. Just say the heat. So it is understood. It's a form of, one form of energy, that one. Okay, then afterwards, the temperature will define the terms temperature. It is a measure of degree of hotness and coldness of a body. These are the, I think, high school definitions, what everyone knows. Hotness and coldness of a body, that one. So this was earlier definition. Now modern definition says, what it says, like the vibration means as you increase temperature, what actually we do notice. So we do notice that there'll be increase in amplitude of vibration of atoms in a material. So if an atom, if the body is at higher temperature, then there what we can see that the atoms will be vibrating it, will have more amplitude of vibration. Means a given atom, so it will have vibration like this. They'll be vibrating about their mean position. Now, if this is a say temperature T1 degree Celsius, then as I increase temperature, look at the arrow, the length of the arrow, it shows that the amplitude, then its amplitude of vibration will increase. Means it will try to move. What do you mean by amplitude of vibration? Earlier, for one temperature, it will be like this. Now, as I increase temperature, it will have more amplitude of vibration. So T2 greater than T1. So as we increase temperature, so definitely what will happen? The amplitude of vibration of atoms about their mean position will increase. So nothing but it's a measure of the random vibration of atoms about their mean position in a material. If they vibrate more, then definitely what will happen? The temperature is said to be more, that one. So this was earlier definition what we said. No, this is the modern definition is what we are using here. So as we increase temperature, what will happen to the amplitude of vibration of atoms will increase. So we'll put it here. The amplitude of vibration of atoms increases as temperature increases. Fine. So a body at low temperature, body at high temperature. At high temperature, we can see that the atoms will more rigorously will vibrate about their mean position. Same thing with even molecules, gases also we discuss. So time being will confine ourselves to the solids here. Like this, we can measure the temperature. So what is the unit to measure temperature? Degrees Celsius, Fahrenheit. Different scales are there. Timing, let me use the Celsius scale, that one. Later on in the thermometry, we'll introduce different types of scales. Okay, fine. So this is about the regarding the heat and the temperature. Now, how to get this heat? How to supply heat? A good example: you take a candle. Find this one. So what you can do is there's a candle, no, and there's a flame. So nothing but shall I say this flame is supplying the heat required. The flame is what supplying the heat required, or LPG flame. So what are the different sources like a candle? Candle flame will supply the heat energy. From where this candle flame will get energy? The wax, which will burn out. A LPG cylinder, the liquid petroleum gas, particular water pen, that will be burnt. And what do we get? We get a heat energy. This is the one thing. Then in case of the bulb, a current I flows, and when a current I flows through a resistor, the electrical energy will be converted into thermal energy, and this particular energy will be radiated. Like this, we will get a light energy. So here, what actually the process is, the electrical energy converted into heat energy, and the heat energy is converted into further the radiation, and that's what we say light energy. That particular radiation will be in the visible spectrum, so we are able to see that one. So these are some, we know how to generate heat. There are various methods are there. Or instead of light, no, let me go for heater coil. Now, if I pass a current I, this is a heater coil. How do we get warm water, hot water? When current I flows, there the electrical energy will convert it to heat energy. That heat energy will be absorbed by the water. So what this heater coil is doing, supplying the heat to the water. So these are the various forms through which what happen we can supply heat. So an ET is supplied means it is understood like either I'll be keeping the object nearby flame, or this particular method I'll be using. Some means. I think nowadays in modern life we do have many methods of supplying the heat. Heat is supplied to a body means what does it mean? We are supplying some sort of energy for that one, or nothing but thermal energy, what we can call. Okay, there's a basic idea of the heat and the temperature. Okay, now we'll proceed to the, suppose say if you have a solid, this is at temperature say like a theta 1 degree Celsius. I'm going to supply an heat theta 2 degree Celsius, or say timing 25 degrees Celsius. I'll make it 40 degrees Celsius. What do we see? We see the length will increase, no? Or it can happen like this also. There's a disk. If you increase temperature, it will become like this. Or you can go for cubical box. So as you rise temperature, so this at 20 degrees, 30 degrees, 15 degrees, say 45 degrees. So these are the things it is happening. So what's happening to the dimensions of the object? It is varying. This is called like a expansion. Or you decrease temperature, it will undergo contraction. Expansion, contraction. Don't say compression. Thermal expansion, thermal compression. Yes, you can use that also. Thermal compression. So if you increase the temperature, the size of object will increase. If you decrease temperature, size of object decreases. So this is called like a thermal expansion in general. Okay, now we have to give explanation. Why do that expansion in general will take place here? That is the primary question. Okay, let me start with the atomic theory, that one. All of you know this particular graph, which was very familiar to you. Now look at the symmetry for the graph. Are you able to see? Okay, the blue color line not visible. Now, is it any this curve? Is it symmetric? There's no symmetry, no. For this, there's no symmetry. Is there? What is this? This will be interatomic distance, and this is the energy, potential energy. You say. So now let this be R naught. And as I increase the temperature, so what will happen to the atoms? They start vibrating about mean position. Will I agree? This is what earlier we were saying, no? As we increase temperature. In fact, they are vibrating. So at a given temperature, they'll be vibrating. So as I increase temperature, the vibrations will increase. So now look at this. Look at the part of the graph. I think I'll take some other. Look at this particular arrow. So as I in fact, at any temperature will be vibrating, the vibrations will be very small. So as I increase temperature, if I increase temperature means what I am doing, I am supplying the heat energy to the body. The body will absorb it. Its potential will increase. Then it starts vibrating about this position. Now look at the length here. It is more on this side, no, than this one. So altogether, what will happen to the distance between atoms will increase here. So if you look at the structure, if this is the no, this was the distance R naught. Already you come across this graph in elasticity. Same thing I'm bringing here. Okay, fine. So now the distance has become, say, R1. Now why do it will happen? This is at temperature T1 degrees. This is T2 degrees Celsius. So T2 greater than T1. So this atom will vibrate here. So, and this will also vibrate. Okay, what was the initial separation as R naught? Then as I rise the temperature, the distance between any two atoms will increase. But what is the state of atoms? They'll be vibrating. Let's not bother. Okay, let's not get into the uh, like a solids inside the solid, how the molecules will be there. Let's not bother. Just like a theoretical analysis we'll do with the help of this graph here. So then as the increased temperature, the vibrations will increase. You can see that what is the net displacement will be towards right now. Will I agree? So if it is having say like a 1 micrometer, here 3 micrometer, net displacement how much? 2 micrometer towards right. So therefore, this particular atom which was there, no, so will get shifted. So the mean position will come somewhere here. This will also get shifted. So altogether, what will happen to the distance between atoms will increase. The distance between any two atoms will increase. Why it will increase? Because the net displacement of an atom is towards right. So if you don't permit this to expand, suppose if you don't permit this to expand, so this set of atoms able to make it out now. If let's assume that they are fixed here. How come they're fixed? Because I'm just connecting them to all this end. The wall will not permit it to move this end towards left. So therefore, what will happen to atom now? Will get shifted, no? So this atom got shifted. The net displacement will be towards right. So like that, as you rise the temperature, the distance between atoms will increase. The distance between any 2 points on a body will increase here. This is called like a thermal expansion. Similarly, you decrease temperature, the length of object will decrease. So initially, what was the length of the object? The length of the object is how much? It was, say, L. So now how much it has become? L plus delta L. So what is this delta L? This delta L is called as elongation due to rise in temperature. Getting the idea? This is the basic background of this thermal expansion. If the graph is symmetric, what would happen? If the graph is symmetric, definitely this distance equal to this distance. Then the distance between atoms, what will happen? Between any two atoms will not change. So since the graph was not symmetric about not symmetric about the vertical reference line, so therefore there will be, due to rise in temperature, there will be thermal expansion. This is the primary idea of for this one. If the graph is symmetric, you rise the temperature, the body will not expand. Because of asymmetric curve, the graph is asymmetric about this vertical reference line. That's why there's a thermal expansion. All solids will exhibit this particular property. I want to learn this thermal expansion. I want to learn this thermal expansion. So how to express this thermal expansion? So for that, we'll define a quantity called as quotient of linear expansion of solids. Symbol will be alpha. This is defined as, first let me write formula. Alpha is equal to, this will be delta L by L into delta T. Change in length per unit rise in temperature. It is defined as ratio of change in length per unit